All right, Algebra 1A students, welcome to part 1 of lesson 4.6, where we're talking about functions as we were in our previous video, and starting to define them more concretely, more formally. And we start with the definition of what is called a relation. Okay, and a relation is simply a pairing up of two numbers, one which is called the domain number, and one which is called the range number. Okay, domain number is the x number. Okay, x is always the domain, and y is always the range. Okay, domain is x and range is y. So when we see an ordered pair, like a parentheses 3, 5, the number that's in the domain would be the 3, and the number that's in the range would be the 5. Okay, 3, 5. Domain, range. All right. A function is a specific type of relation, or a special type of relation, where each value in the domain is paired with exactly one value in the range. Here's what that really means. Okay, what that really means is no repeats in the domain. Okay, there's no repeats in the domain with different range values. Okay? So what I'm going to ask you to do in your practice problems is look at some ordered pairs, some sets of ordered pairs, some sets of points from a graph, okay, and tell me what are the domain and the range numbers from those sets. Okay, so this right here in letter A is a relation because it's a bunch of x, y coordinate points. It's a bunch of parenthesis points, domain, range, domain, range, domain, range, x, y, x, y, x, y, x, y, all these points. That's a relation. Okay, they want us to identify the domain and the range for them. So what I'm going to do is I'm going to just write domain, and then I'm going to put a colon, and now I'm going to list out the numbers after this that are in my domain for letter A. Okay, and the first one that I see, well, in the first point I have a -2, 0.5. And as I mentioned up above, the first number is always my domain, my second number is the range. So the domain value for this point is -2. Okay, the domain value in the next point is 0, because 0 comes first, then 2.5. The next point is a 4, and the next point is a 5. Okay, so that's the domain. The range numbers then are exactly the y values in each of those points. Okay, so for the first point, it's 0.5 is the second number. The second point is 2.5. The third point is 6.5, and the last one is 2.5. Okay. Now they also want us to do something called a mapping diagram. So let's talk a little bit for just a second about what a mapping diagram is. The mapping diagram is very much like a table of values that we have been doing in previous sections to graph things. So it kind of looks like this, x and y, except now we don't use x and y anymore. Now we say domain and range. Okay, now we say D and R for domain and for range. Okay, and again, I can list these numbers out. Domain and range, domain and range. Well, my domain is right here, -2, 0, just 0, then 4, and then 5. Okay, the one thing that we need to keep in mind is that when we do a mapping diagram, in a mapping diagram, don't list repeats. Okay, we do not list the repeats in a mapping diagram. That's very, very important. Please do not list the repeats in a mapping diagram. Okay, so I've listed all my domain numbers, -2, 0, 4, and 5. Now I will do the same with my range numbers. Okay, my range numbers are 0.5, 2.5, 6.5, and a 2.5 again, but I don't have to list that because it's a repeat. Okay, so again, don't list the repeats. When we list them out, we do sometimes. And actually, I don't think we need to here either. So let's cross out that 2.5 in the range because we don't have to list repeats there either. Okay. Now I'm basically ready to finish my mapping diagram here, and all I do in a mapping diagram is I connect with arrows the domain numbers to their range numbers. Okay, so the 2 goes with the 0.5, the 0 goes with the 2.5, right, from up here, the 4 goes with the 6.5, and then the 5 also goes up with the 2.5. Okay, so I just list out my domain and my range, and then I connect them with arrows. Okay, now in a mapping diagram, as long as each domain number has just one arrow coming from it, it is a function, okay? Because that's the last question that they're asking us here. Is the relation a function? So the answer here is absolutely yes, because every one of my domain numbers has just one arrow coming off of it. Even though 2 of the numbers are going to 2.5, because each domain number only has one arrow coming off of it, then that is most definitely a function, okay? So please make sure these 2 things get written down here. In a mapping diagram, don't list repeats. And as long as each domain number has just one arrow, it is a function. The answer here is yes. I would like you to try letter B on your own for a couple minutes, listing the domain and the range, making me a mapping diagram, and then telling me if it's a function or not a function. Okay? So pause the video for a second, take a look at that. Letter B here, decide if it is a function or not after listing the domain and range and making a mapping diagram. Once you're finished, come on back and I'll show you what we should have. Right here, our domain is 6, 4, and 5. I don't have to list the repeated 6 again. 6, 4, 6, 5, 6, 4, 5 are my different domain numbers. My range numbers are 5, 3, 4, and 8. No repeats there. Again, I'm going to make a mapping diagram now, which again looks like a table of values. Domain, range. Okay, my domain numbers, as I mentioned, 6, 4, 5. My range numbers, 5, 3, 4, 8. And now I am ready to connect my arrows. So looking back at the first point in this relation, 6 goes with 5. The second point, 4 goes with 3. Looking at the third point, 6 goes to 4. And then 5 goes to 8. Okay, but now I have a very serious issue with this mapping diagram. Look at the number 6 in my domain list. It has 2 arrows coming off of it, one to the 5 and one to the 4. So this is not a function. Why is it not a function? Because my mapping diagram has 2 arrows coming from it. Okay? So that's one really good way to decide if something is a function or not a function. And that's simply looking at the mapping diagram for that relation. If there's not more than one arrow coming off of any of your domain numbers, you're fine. But if there is, because of a repeated domain number, right, a 6 there and a 6 here, then we have to say no, it's not a function at all. Okay? Now, on a graph, this looks slightly different. Okay, another way to decide if a relation is a function is to analyze the graph using what's called the vertical line test. Okay, and that just means if you take any point on the graph and draw a vertical line straight down through that point, it is not allowed to hit any other points on the graph. It's never allowed to hit the graph ever again. Okay? So if any vertical line passes through more than one point, then it is not a function. Okay, so look at this. In letter A, they've plotted all these different points. -4 in the x, 2 in the y, -3 in the x, 1 in the y, 0, -2, -4, -1, and 1, 2. And they've drawn vertical lines through all of their points. The problem comes right over here, because if this vertical line hits these 2 points right here, that's a big, big problem. So that relation is not a function. Okay, but if you look at this graph over here, These are all points on this graph, okay, going around this curve, this big curve called a parabola, right? And this big curve called a parabola, if you draw a vertical line through any point on this curve, it will only hit the curve one time, right? It never hits again. It keeps going away from these vertical lines. So this is good. It is a function because there's no vertical line that passes through more than one point on that graph. Okay, I would like you to try just for a minute sketching a graph of all of these points here. So again, just sketch a graph here for letter A. Graph these 5 points and see if this passes the vertical line test and tell me if that is a function or not. Take a minute to graph those points. When you decide if it's a function or not using the vertical line test, come on back and I'll show you what we should get. All right, our points should be at 4, 2, 1, 2, 0, 1, negative 2, 2, and 3, 3. Okay? Now, of those 5 points, if I draw a vertical line through any of them, that vertical line only hits 1 point. Right? None of them ever hit 2 points. There's one here, one here, one here, one here, and one here. It never hits twice. Okay? So this relation is most definitely a function. We would say yes. If you have questions about what a function is, or how to figure out if one is one from either a mapping diagram or using the vertical line test, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.